Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into building a SQLite database, specifically, parsing metadata from the schema table. It's incredibly cool.
Right, I'm really excited about this. So the core idea is to go beyond just listing tables and actually understand their structure, right? We need column names and types, not just table names.
Exactly. The schema table, residing on page 1, holds all this juicy information. We already know how to get the table name and root page. Those are straightforward. But the column details are tucked away in a create table statement within a single field. That's where the fun begins.
Parsing the create table statement. That sounds like a classic parsing problem. What kind of approach are we taking? Lexical analysis?
You bet. We're using a tokenizer to break down the create table statement into individual tokens. We've added new tokens like create, table, and to our token enum. It's all in the tokenizer.rs file. Pretty standard stuff, but crucial.
I see. And then, an abstract syntax tree, AST, I presume, to represent the parsed structure?
Absolutely. We've extended our AST in ace.rs with a create table statement struct. This struct neatly holds the table name and a vector of column def structs, each representing a column with its name and type. It's a very clean representation.
Elegant. So how do you handle the different column types? Are you using a simple string match or something more sophisticated?
It's a straightforward match in the parse_type method within parser.rs. We support integer, real, text-t, string, and BLOB for now. Simple, but effective. We can always expand this later. More types can be added later.
Makes sense. Keep it simple for now. And the parsing of the create table statement itself? How does that work?
The parseCreateWhenable method in parser.rs handles that. It's a recursive descent parser, expecting the tokens in the correct order. It uses the parseColumnDef method to handle each column definition. It's quite elegant, really.
And the semicolon? Is it mandatory?
Good question. The semicolons are optional in the schema table, so we've updated the parse_statement function to handle both cases. That's a nice touch.
Excellent. So once you've parsed the create table statement, how do you integrate that into your database structure?
We've added a table metadata struct to hold the table name, columns, and the first page number. The table metadata from cursor method extracts this information from the schema table's cursor. We also added a collectibles_metadata method to the dflat struct to efficiently gather all this metadata.
So the dflat struct now holds all the metadata. That's a significant improvement. How does this affect the .table command?
The .table command is now much simpler. Instead of manually scanning the schema table, it just iterates through the table's _metadata vector in the dflat struct. Much cleaner and more efficient.
This is a really solid piece of engineering. I'm impressed by the clean separation of concerns and the elegant parsing logic. One thing though, the error handling seems quite basic. Could more robust error handling be implemented? Perhaps using a more sophisticated error reporting system?
You're right, that's a valid point. More robust error handling, perhaps with custom error types and more informative error messages, would definitely improve the code's robustness. That's something to consider for future improvements. Good catch.
Absolutely. But overall, this is a fantastic step towards a fully functional SQLite clone. Looking forward to the next part.
Thanks. And that's a wrap for today's episode of Tech Bytes and News. We hope you enjoyed this deep dive into the world of SQLite metadata parsing. Join us next time for more exciting developments in our journey to build our own SQLite database. Goodbye.
Bye-bye.